Hey friends, so I've decided I want to call this lesson the case of the exploding coffee mug. No, it has nothing to do with that. But as I was getting ready to record, I was making a cup of coffee and the pod exploded all over the place. So I had to clean up that and make a new cup of coffee, which still coincidentally has some grinds in it left over from the explosion, but that's okay. Okay, so today we are going to take a look at applications of quadratic equations. So this is the last lesson in a very long unit on quadratics. You'll recall that the first half dealt with quadratic functions, and then in the second half we have been dealing with quadratic equations and finding the solution to quadratic equations. So we've looked at solving by graphing, we've looked at solving by factoring, solving by completing the square, and then in the last lesson we did the quadratic formula and the discriminant. Okay, so that's where we are. So now we're going to end this section just like we ended really the section with quadratic functions. We're going to look at some word problems together and how we can kind of use this in real world situations. Okay, so whenever you're doing word problems, these are kind of the steps that I want you to be thinking about as you do them. Okay, so you want to define your variables. So I know I talked about that in the last application section that we did, but if you don't say let x equal whatever, the rest of your problem, the rest of your beautiful work is meaningless because you've never defined what x was in the first place. So that is super, super important to define your variables. Then you want to create your equations, solve and verify your answers, and then answer the question. Give me some sort of a concluding sentence that actually answers the question that you were asked in the first place. Okay. All right, so let's get going on it. We'll do a couple of these together, and then I'll leave you alone to try it on your own. A number and its reciprocal have a sum of 5. Determine the number. Well, first of all, we want to let x equal that first number, okay? Then we know that the reciprocal would be 1 over x, okay? So we're going to say x is our first number, so I've defined my variables. The reciprocal is 1 over x, and I know the sum is 5. So my equation becomes x plus 1 over x equals 5, okay? Now, what I'm going to do, some of you may look at that and say, that doesn't even look like a quadratic. Well, give me a second, because I want to get rid of that division of x right here, okay? And so to do that, I multiply each term by x. So I'm going to multiply all my terms by x so that I don't have fractions there anymore. That's going to give me on this guy, x times x is x squared. I'll get a 1 here, because my x's will divide each other out. And then on this side, I'll get a 5x. So I've got x squared plus 1 equals 5x. There's the quadratic I'm going to work with. I'm going to rearrange it so that everything's on one side. So essentially, I need to bring that negative or that 5x over. So it'll be negative 5x. Okay. And then I brought my 1 over as well. So that'd be negative 1. Okay. Now, the reason I did that is because I could just tell with these numbers, it's not going to be a factorable item. It's not going to be nice that way. So I'm just going to go right into solving by completing the square. So I want to make a perfect square trinomial out of this x squared minus 5x here. Okay, so I just got the 1 on the other side so that I can focus on getting that trinomial. So I want to add in a number here. What do I need to add in? It's half of 5. Well, half of negative 5 is negative 5 over 2. And then I want to square that. So that's 25 over 4. You square the top, square the bottom. Okay, so 5 squared is 25, 2 squared is 4. So I'm going to add 25 over 4 to both sides of my equation. Okay, so now here, for simplicity's sake, I'm going to call negative 1 negative 4 over 4. Okay, that way I have a common denominator, and then I can just add these in my head. Negative 4 plus 25 is 21. So over on the right there, I'm going to have 21 over 4. And then over on the left, well, I know that that now factors into a binomial squared. What is the binomial? It'll be x minus 5 over 2. Okay, remember the first term is the square root of the first term. The last term is the square root of the last term. And the sign in the middle is the sign in the middle. Okay, so that's where I am. X minus 5 over 2 all squared equals 21 over 4. Now, I would square root both sides. When I do that, this is going to be plus or minus, and it's going to end up being root 21 over 2 because I'd be squaring root 21 and squaring 4. but I know the root of 4. The root of 4 is 2. So I'll have x minus 5 over 2 equals plus or minus root 21 over 2. Now I just have to add 5 over 2 to both sides to get x by itself. And that's actually friendly because I already have a common denominator. So my final answer I can put as one big fraction already, and it will be x plus or minus root 21 all over 2. Okay, those are my two numbers. Okay, there are two possibilities where when I add that number plus its reciprocal, I would get out 5. Okay, so there are two possible numbers, 5 root 21 plus over 2, sorry, or 5 negative root 21 over 2. Okay? See? This is easy. We can do this. Okay. 3 pieces of wire have lengths of 20 centimeters, 41 centimeters, and 44 centimeters. The same amount is cut off each wire so that the pieces form a right triangle. Determine the area of the triangle. Now, I'm going to hide myself for a second just because I want you to see the question, because the key word here is a right triangle. A right triangle means I have a 90 degrees. Not only does it mean I have a 90 degrees, it also means I get to use the Pythagorean theorem. Okay, so what I'm going to do here is I'm going to call x the amount that I subtract, because it says the same amount is cut off each wire. Okay, so if I subtract x from each item, then I'm looking at 20 minus x, 41 minus x, and 44 minus x. Okay, I also know that it's the 44 that has to be my hypotenuse, because the hypotenuse would be the longest side. So I'm going to put those three numbers, 20 minus x, 41 minus x, and 44 minus x, into the Pythagorean theorem. So I have 20 minus x all squared plus 41 minus x all squared. It's the two legs squared and added together will equal the hypotenuse squared, which will be 44 minus x all squared. Okay. So we're here at the moment. Okay. Now, you got some math to do here. Remember, the exponent of 2 does not just go on to both of those numbers. You either have to go 20 minus x times 20 minus x and then FOIL it first, outside, inside, last. Or you just remember my little, my saying there, square the first, double the product, square the last, will also square the binomial for you. So square the first, double the product, square the last, and I have to do that for each one. Okay, so if you haven't paused me to do that, you should, because you want to make sure you're doing it right before you see the answer. Everything's easy when I show you the answer, right? That's why you got to shut me up and make sure you can get the answer yourself. That, and sometimes it's just therapeutic to shut me up. Okay, this is what you should have. 400 minus 40x plus x squared. Whoops, sorry. That's going to be this guy squared. And then the 41 minus x all squared gives me 1681 minus 82x plus x squared. Square the first, double the product, square the last. And then the last guy gives me 1936 minus 88x plus x squared. Okay, so now I'm just going to work on the left side for now and just combine like terms. I've got x and x that can, or sorry, x squared and x squared that can combine together. I got negative 40x and negative 82x that can be combined together. And I got 400 and 281. 1681 that can be combined together. So all together, that's going to leave me on the left side, 2x squared minus 122x plus 2081. Sorry. Okay, and then I haven't done anything on the right side yet. Now I'm going to move everything over to one side. Okay, so I'm going to subtract x squared from both sides. I'm going to add 88x to both sides, and I'm going to subtract 1936 from both sides. Okay. That leaves me here. So now I want to go ahead and see if I can factor this. Okay, so I'm looking for two numbers that multiply together to give me 145 and add together to give me negative 34. That tells me both of my numbers have to be negative. So let's try a few things. 145 divided by 15 doesn't work. 145 divided by 5 is 29. 29 and 5 is 34, that works. Okay, so I'm gonna have x minus 5 and x minus 29. Okay, so now I'm at the zero product principle. Either the x minus 5 equals 0 or the x minus 29 equals 0. Okay, so I split that up into the zero product principle. That tells me x equals 5 and x equals 29. These are both values that would work in the equation and render a true statement. But do both values work in the context of the question? And the answer is no, because one of my lengths is 20, and this x represents what I'm taking away. So if one of my lengths is 20, I can't possibly take away 29, right? That would leave me with a negative length. So the 29 actually doesn't work in the context of this question. It works in the equation, but it's meaningless in the context, okay? So I said this value does not work in the context of the equation because it would cause a negative length. So actually I'm only working with the x equals 5, okay? And so now I haven't answered the question yet because the question said, what's the area of the triangle? Well, remember, maybe you don't know this. I'm hoping a junior high teacher taught you this along the way, but when I have a right triangle, the definition of base and height is that base and height have to form right angles to each other. So you could call this the base and this the height, okay? Which means the two legs of your right triangle would be your base and height. So what I did was I took the 20 and I subtracted 5 to get me the 15. And then I took 41 and subtracted 5 to get me 36. So my base and height of this triangle are 15 and 36. So now I plug that into the area formula. Area of a triangle is base times height divided by 2. So I'll go 15 times 36 divided by 2. And that gives me 270 centimeters squared. Okay, so the area of the triangle is 270 centimeters squared. Okay. Yay. All right. An Olympic swimming pool with dimension of 90 meters by 60 meters is being built in a gym that has an area of 9,000 meters squared. If there's to be a sidewalk of uniform width all around the pool, how wide will the sidewalk be to the nearest tenth of a meter? Okay, so what are we looking at? We want to try and get a visual here for a second. So here's my pool, okay? And what we're going to do is we're going to put a sidewalk all the way around it, okay? And the sidewalk is of uniform length. So what that means is this guy and this guy and this guy and this guy are all the same. So that's what I'm going to actually define as x, okay? Is that width of the sidewalk. Okay, so I'm going to define my variables now. I'm going to say x is the width of the sidewalk, okay, or the walkway. And now I need to come up with an equation. Well, I know that the pool was 90 by 60, so the width of this whole thing would be the 90 plus the sidewalk on this side and the sidewalk on this side. So that would actually be 90 plus 2x. And same thing for the other dimension, it would be 60 plus 2x. You've got a sidewalk on this side plus a sidewalk on this side, okay? So my equation becomes 90 plus 2x times 60 plus 2x equals 9,000. Now, I'm not ready to do anything with this because it doesn't equal 0, so it's not in factored form. I'm gonna have to multiply this all out, and I'm gonna then subtract 9,000. So you should pause me and go ahead and do that so we can compare answers in a sec. Okay, and so that should have given you 5,400 plus 180x plus 120x plus 4x squared equals 9,000. I'm gonna rearrange it so that it's in order, x squared, x, and then number. I'm also gonna subtract 9,000 from both sides so that it equals 0. And that leaves me with 4x squared plus 300x minus 3,600. Personally, I see that and think, okay, I want to divide everything by 4 so that my numbers are a little smaller. And that'll give me x squared plus 75x minus 900. Now, I could start factoring this, but I don't want to because there's a hint in the question. The question said round to the nearest tenth of a meter. If the question says round to the nearest tenth of a meter, that probably means this is not a factorable question. So I'm not even going to bother trying to factor. I'm actually going to go straight to the quadratic formula for this guy. Okay, so my A value is 1, my B value is 75, and my C value is negative 900. Okay, so I plug all that into the quadratic formula. I'm going to work on getting the stuff underneath the square root to be one number, which is 9,225. Okay, now if I was answering in the quadratic formula, I would want to simplify 9,225. I can at least take a 25 out there, maybe something more. But I'm not going to do that because I'm going to go right to a decimal approximation anyway. So I'm going to go negative 75 plus the root of 9,225 all over 2, and negative 75 minus the root of 9,225 all over 2. That's going to give me two answers, 10.5 and negative 85.5. I need to see both of those, okay? I know I just scratched out the negative 85.5 right away, and I want to talk to you about why in a second, but you need to show me both answers, and then you need to show me what answers you're scrapping because of the context of the context of the situation. So in this one, we are talking about the width of a walkway. I can't have a negative width. That would be a severe glitch in the matrix. I can't have a negative width, so that one's gone, and I'm just going to go with a 10.5. Okay, so make sure you answer the question. The width of the hallway is 10.5 meters. Okay. All right, so that is, let me get the ink off there for you. That's what you're doing today. I've got your homework listed there. Make sure you're following all that steps. Make sure you define those variables. And make sure you conclude, answer the question, okay? And have fun along the way, okay? If you have any questions, make sure you connect with me, and we'll talk soon. Take care, guys.